Section 1.4, number 14. We're given a function h of t is equal to the square root of 4 minus t squared. And we're told to first graph the function, which I have done here, and estimate the domain and the range. So the domain is all of the x values where this thing exists. Now this looks like a half of a circle. In fact, it ends up being half of a circle. But it looks like it exists from -2 all the way out to 2. And it looks like the endpoints exist. It's tough to tell. But I'm going to say that the domain is going to go from -2 to 2. And I'm going to say that it includes the endpoints based on the graph. Now the range is all of the y values that have something that have something in them. And it looks like all of the y values go from 0 all the way up to 2. Now it definitely looks like it gets to 2. It sure looks like it gets to 0. So I'm going to say the range is going to go from 0 to 2. Now the second part says to try to determine the domain and the range algebraically. Now since we have a square root, the domain is going to be determined by the thing inside of the square root being greater than or equal to 0. So we're going to need 4 minus t squared greater than or equal to 0. Okay. Now I can add t squared to both sides. So this will give us 4 is greater than or equal to t squared. Right? And now we need to do a square root. Okay. So if t squared is less than or equal to 4, when we do the square root, we're going to get 2 is greater than or equal to t, okay, or -2 is less than or equal to t, okay, and since we are greater than or equal to one number and less than or equal to another number, can we get these things to fit together? Well, -2 less than or equal to t less than or equal to 2. Well, -2 is less than or equal to 2. So this is our domain. Right? So that's going to be our -2 to 2. And it is including the endpoints because we got these equalities here. Right? This equality leads to this. This equality leads to this being square. Now what about a range? Okay. The square root is designed to be positive. All right, so the only way that can be 0 is if the thing inside is 0. Well, the thing inside is 0 whenever t is equal to positive or -2, right? Is 4 minus t squared equal to 2, question mark? Okay. Sorry, 0, question mark. Okay, well, we solve this the same way. 4 is equal to t squared. So t is going to be equal to either 2 or t is equal to -2, right? And both of these guys are in our domain. So the square root of 0 is 0, so the range being 0 certainly makes sense. Now, every other value here, well, where are we going to get a maximum? Well, we're going to get a maximum whenever the thing inside the square root happens to be a maximum. Right? The thing inside the square root happens to be a maximum when t is equal to 0. Right? That's our tippy top there. Right? So the max occurs when t is 0. The max when t is 0 is max is equal to the square root of 4 minus 0. Square root of 4 is equal to 2. And we do get there. 0 is in our domain. So this is going to be our maximum. Now, since 4 minus t squared is a polynomial, polynomials are continuous. Square roots are continuous. So we're certainly going to get all of the pieces in between. So our range is in fact 0 to 2. And there we have it. We're done.